Hi guys, welcome to this Edexcel A-level Mathematics paper. This is the paper 1 from the June 2018 series. So I'm going to try and go through this paper and give you some good hints and tips to answer in these questions. I'm going to try and do it in one take as well, so we'll see how that goes. So it's always a good idea to read the front. So you have a calculator for this exam, you have the formula booklet, which is helpful. So we'll just crack straight on now. So question 1. Given that theta is small and measured in radians, use the small angle approximations to find an approximate value of this expression here. Now these approximations are in the formula book, so I'll just write them down. We don't need the one for tan theta right now, so I'll just write down the first two. So sine theta is approximately theta, and cosine theta is approximately 1 minus theta squared over 2. So using these then we can approximate the terms in the numerator and the denominator. So we can see that cos 4 theta is approximately 1 minus 4 theta squared over 2, which equals 1 minus, and then 4 theta squared is 16 theta squared, divided by 2 is 8 theta squared. Similarly, sine 3 theta is approximately 3 theta. Now we can plug these values in to get an approximate value of our expression. So 1 minus cos 4 theta divided by 2 theta sine 3 theta is approximately, so it's 1 minus, and then it's good to bracket here, it's 1 minus 8 theta squared, and then we're dividing by 2 theta times 3 theta. This is equal to, the 1's are going to cancel out, minus 8 theta squared is 8 theta squared, and then on the bottom we've got 6 theta squared. The theta squareds cancel and we're left with 4 over 3. So that's the answer for question 1. Question 2, we're given a curve with this equation here, x squared minus 2x minus 24 square root x, where x is bigger than 0. And we're asked a few things. We're asked to find the first and second derivative. We're asked to show that c has a stationary point when x equals 4. And we also are asked to determine the nature of this stationary point. When we have an expression involving square roots like this, I always like to rewrite the equation as follows. So we just change the square root using indice notation. So y equals x squared minus 2x minus 24, and then square root of x is x to the half, because we have this basic property of indices that a to the 1 over m equals the mth root of a. So that's where that comes from. Now we can see this expression for y we have is easy to differentiate. We just use the normal rule, which I'll write here. So x to the n differentiates to n x to n minus 1. So that's the basic rule for differentiation. So let's do that here. And we get dy by dx equals 2x minus 2. And then for this last term, we do 24 times a half, which is 12. And it's still a minus. And then we take 1 away from the power. A half minus 1 is minus a half. So that's that. So that's our part I for A. And then part II we're asked to differentiate this again. So we just do the same thing again. 2x goes to 2, minus 2 goes to 0, any constant goes to 0 in fact. And then for the last term again, we do minus 12 times minus a half, which is plus 6x. And then minus a half minus 1 is minus 3 over 2. And I'm not rushing these questions, guys, so just trying to take it nice and slow, make sure we don't make any silly mistakes, because that can always happen under the pressure of exams and whatnot. So there you go, we have the two derivatives. Now verify C has a stationary point when x equals 4. Let's go ahead and do that. So stationary points are when a curve has no gradient. So if we've got a curve like this, then this point here is a stationary point, as there's a tangent to the curve, and tangents like this have no gradient. So what we're looking for is when, well, we're essentially trying to show that when x equals 4, dy by dx equals 0. So let's do that. So when x equals 4, dy by dx equals, so it's 2 times 4 minus 2, and then we've got this minus 12x to the minus a half. Now another basic rule of indices is, I'll just write it here, so if we have x to the minus n, this is actually equal to 1 over x to the n. Another basic rule of indices there. So I'm just going to bring this x to the minus a half down to the bottom. So we get minus 12 over, and then it's 4 to the power of a half, which is, by our other reasoning above, the square root of 4. So let's carry on then. Separate that. So 2 times 4 is 8, minus 2, minus 12 divided by the square root of 4 is 2. And you should be able to see there that we've got 8 minus 2 is 6, minus 12 divided by 2 is 6, which is 0. So there we go. So you don't have to do this, but I'm going to do it. So when x equals 4, dy by dx equals 0, and then get my pen to work. Therefore, C has a stationary point. I'm just going to put STPT when x equals 4. So there we go. So that's part B. Part C, determine the nature of this stationary point, given a reason for your answer. Now there's a couple of ways we can do this. One way is to use the second derivative, and we can also do it using the first derivative. But as we've calculated the second derivative, we might as well use it. So all we have to do here is plug in x equals 4 to the second derivative. Do that there. Part C. When x equals 4, d squared y by dx squared equals, so it's 2 plus 6 over 4 to the 3 over 2. Now one way to think about this, I'll just write out another little rule. So if we have, just a general rule here, so if we have a to the m over n, this actually equals the nth root of a to the power of m. So we can apply that to our expression here. So we get 2 plus 6 over, so it's going to be the square root of 4, which is 2, cubed is 8. And this is going to give us, so if we change the 2 so it has a denominator 8, that's 16 over 8, it's 22 over 8, which equals 2.75. The main observation here is that this is greater than 0, so let's write when x equals 4, d squared y by dx squared greater than 0, hence the stationary point is a minimum. We can see why this makes sense, because we have our curve here, we have our stationary point, then the gradient is increasing. So that means it's a minimum. If it was the other way, and if the gradient was decreasing after the point, then we'd have a maximum. So that's the answer for that question. Moving on. Question 3, we've got a question about sectors and arc length. So there's two main formulas to remember here before we even look at the question. So arc length, that's this AB here, this length. This is r times theta, where r is the radius and theta is the angle. And then the area of the sector is a half r squared theta. So they're the two main formulas you need to remember about sectors and arc length. The rest, with those two, you should be able to answer most questions. So here we go. Let's have a look at the question. So we have a sector AOB of a circle with centre O and radius r. The angle AOB is theta. The area of the sector is 11 centimetres squared. Given that the perimeter of the sector is 4 times the length of the arc AB, find the exact value of r. So, what we need to do here is, firstly, we're given that, change pen here, we're given that the area of the sector AOB is 11. So immediately we can plug into our formula, a half r squared theta equals 11. That's that. And then, given that the perimeter of the sector is 4 times the length of the arc AB, find the exact value of r. So the perimeter is OA, this length, plus AB plus OB. So, let's draw a line. Perimeter, the perimeter is 2r plus r theta. So we've got an r there, and an r theta for the arc length. And it says that this expression is 4 times the length of the arc AB. So let's do that. So this actually equals 4r theta. Now from here, we can manipulate this expression to get a value for theta. So we can move the r theta to the right hand side, and we get 2r equals 3r theta, and then divide by 3r to get our value for theta. This symbol here means implies. So we have 2r over 3r, which equals 2/3, as the r's cancel. So now that we have a value for theta, we can plug it into here to find the value of r. So a half r squared times 2/3 equals 11. The 2's cancel, and we're left with r squared over 3 equals 11. This gives us that r squared equals 33. And now finally we obtain the answer, r equals square root of 33. Note that when you normally take a square root, you take both the plus and minus, but in this case the radius has to be positive. You can't have a negative radius of a circle, it doesn't make sense. So this is the one and only answer here. Moving on. Question 4. The curve with equation y equals 2 times the natural log 8 minus x meets the line y equals x at a single point x equals alpha. So the first part of the question is to show that this root alpha lies in between 3 and 4. So the simplest way to do this is express the curve and the line as a function. Sorry about that. So what I mean by that is So we have the curve 2 natural log 8 minus x, and we have y equals x. Now as they both equal y, we can write 2 natural log 8 minus x equals x, and then we can write 2 natural log 8 minus x equals 0, and then we can set this left hand side to be equal to some function f of x. And what this allows us to do is to input certain values of x and calculate the result. Now don't forget you have a calculator for this exam as well, so you're not expected to work out the natural log of numbers. So now let's input 3 and 4, and what we're looking for is a change of sign. F of 3 equals 2 natural log 8 minus 3 minus 3. And you can plug this into the calculator, as I'm doing now, 2 natural log, and you get 0.22. That's to 2 decimal place there. Similarly, f of 4 equals 2 natural log 8 minus 4 minus 4. And no prizes for guessing that this is going to be a negative number. Indeed, it's minus 1.23. So that's that. And yeah, so this function is continuous here as well. There's no breakage in the curve or the line. And then to round up this question, you'd probably say something like, as f is continuous, CTS means continuous, in interval 3, 4, and there is a change in sign, we must have that 3 is less than alpha, which is less than 4. So that's that part of the question. Moving on to part B. Here we have this simple iteration formula which expresses the next term in terms of the previous term. So we're starting with x1 equals 4. So determine whether or not this iteration formula can be used to find an approximation for alpha. So what we do here is we draw the cobweb diagram, which I'm going to try my best to draw on this graph. So we start at x1 equals 4, we go up to the curve, then we go left along to the line, up to the curve, and so on. And you can see that the cobweb curve is spiraling inwards and it's converging towards the root alpha. And therefore, because of this, you probably write something like this. You put as cobweb diagram spirals inwards, it converges to alpha. This means we can use the formula. To approximate alpha. So that's the answer to that question. Let's move on now to question 5, and we've got some trigonometry. So we have this function here of y equals 3 sine theta over 2 sine theta plus 2 cos theta, where theta lies in between these values. And we're asked to differentiate this y with respect to theta and show that it's of this form. Note it also says here that the constant we're trying to find is rational. This means that it's of this form. So it's no good if we have just a whole number on the top. It needs to be of the right form. So let's go ahead and approach this. So we're trying to differentiate a quotient here, which means we need to use the quotient rule, of course. So I always like to write down the functions u and v. So u is 3 sine theta. Sorry, my handwriting's getting progressively worse here, but we'll carry on. 2 sine theta plus 2 cos theta. So let's differentiate these. U primed. We know that sine differentiates to cos, so we just get 3 cos theta. And we know that, again, sine differentiates to cos, so we get 2 cos theta. But here, cos differentiates to minus sine, so don't forget the minus sign there. So there's our values for u, v, u primed and v primed. Now all we have to do is apply the quotient rule. And it's important to get the order right as well. So dy by d theta. So first we take v and multiply it by u primed. So we have 2 sine theta plus 2 cos theta, multiply by 3 cos theta. And then we're going to take away u, which is 3 sine theta, times by v primed, which is 2 cos theta minus 2 sine theta. Just about got enough space there. And then we also have to divide by v squared, which is 2 sine theta plus 2 cos theta. And this is all squared. So let's expand both the numerator and denominator here. So 2 sine theta times 3 cos theta is 6 sine theta cos theta. That's our first term. Next we have 2 cos theta times 3 cos theta, which is 6 cos squared theta. Next we have minus 3 sine theta times 2 cos theta, which is minus 6 sine theta cos theta. And minus 3 sine theta times minus 2 sine theta is plus 6 sine squared theta. Let's expand the bottom as well. So we have 4 sine squared theta plus 4 cos squared theta. And then we've got 2 lots of 2 sine theta times 2 cos theta. So we have 8 sine theta cos theta. Now, this might look quite complicated, but straight away before we do anything, we can see that these two terms cancel. 6 sine theta cos theta and minus 6 sine cos theta, sine theta cos theta. Next, we're going to need some trigonometric identities. The first one is that for any angle theta, we have this equality. Sine squared theta plus cos squared theta is 1. And the second one we need is the double angle formula. Sine 2 theta equals 2 sine theta cos theta. Now, this second one can be deduced from the addition formulae, which are given in the formula book, but I think it's best to learn them. So it'll just get it into your head quicker and you'll be able to work these problems out quicker. So now let's have a look what we have on the top. We have 6 lots of sine squared theta plus cos squared theta. And on the bottom we have 4 sine squared theta plus cos squared theta. But we also have 8 sine theta cos theta, which is actually 4 lots of sine 2 theta. So we have this. So let's simplify this. 6 divided by 4 is 3 over 2. Sorry, I shouldn't write it like that yet. just keep it as it was for now. 3 over 2. We have a 1 on the top. So this is really bad notation, but I'm just trying to make it nice and simple. And then we have a 1 plus sine 2 theta. Now you might be tempted to expand these brackets out and call it a day there, but recall that the number a has to be rational, which means it has to be a fraction. So we still have a tiny bit of work to do. So right now we have 3 on the top over 2, 1 plus sine 2 theta. I'm going to go on to the next page here. So all we have to do now is divide by 2 on top and bottom. And this gives us our final answer of 3 over 2 over 1 plus sine 2 theta. So our constant we had to find was 3 over 2. That's the final answer for this one. Question 6, we have some coordinate geometry here. So we have a circle and we have a line tangent to the circle at this point P. The centre of the circle is the coordinates 7, 5. And yeah, we're given that this line has equation y equals 2x plus 1. So we're in part A, we're asked to find the equation of the line A. PA, sorry. So that's this line. And it's actually the radius of the circle, this line. So now, we're given that the line L is a tangent, so let's just draw a little mini sketch out here. So we have this circle, but then we also have this. So this was A, this was P, this was L, and we have the line L is y equals 2x plus 1. We're trying to find PA. So note first that the lines PA and L are perpendicular. So let's write this. L is perpendicular to PA, which means their gradients multiply to minus 1. This is just a basic property. If we have two lines L1, L2, and L1 is perpendicular to L2, that's what this symbol means, where L1 equals M1 x, trying to not make this complicated, but I'm just trying to write down what I mean. L2 is M2 x2 plus C2, then M1 M2 equals minus 1. So that's what I mean when I've written out this paragraph here. So let's carry on. So hence the gradient of PA is minus a half. So now we have the gradient of PA and we also have a point on it, namely A. So we have the point A equals 7, 5. Now we just use the equation of the line formula, which is, so it's y minus y1 equals mx minus x1. So let's plug in our values. Y1 is 5, gradient is minus a half, and x1 is 7. So now let's multiply by 2 to get rid of that fraction there. So we have 2y minus 10 equals minus x plus 7. And now it's just a case of rearranging. So we get 2y plus x equals 17. And that's the equation we were after, if we recall. So that's there. Now, find an equation for C. So before, just change pen here. So part B, find C. So before we do that, let's write down the equation of a circle. So it's x minus a squared plus y minus b squared is r squared, where AB centre and r is the radius. Hope all this seems very familiar to you. So, in order to do this, we need to find the radius. We have the centre, so we just need the radius. We also need to find P, the point P, the coordinates of the point P, because in order to find the radius, we need to know P, and then we can use the length Pythagoras theorem. Now, in order to find P, this is the intersection of the lines P, A, and L. Okay, so let me write that down. To find P, solve L and PA simultaneously. So, recall we have the equation for L was, what was it, y equals 2x plus 1. And then PA, we had, just wrote it down, 2y plus x equals 17. So let's substitute this into here. So we're going to get 2 lots of 2x plus 1 plus x equals 17. We're going to get, let's expand these brackets, so we get 4x plus 2 plus x equals 17. And then we can just rearrange to get this. So we've got 5x equals 15. 15, and therefore we get x equals 3. Now to find the y coordinate is simple, just plug in x to the first equation, or either equation actually. So y equals 2 lots of 3 plus 1, which equals 7. So now we have our point P, which is 3, 7. And we had A, which equals 7, 5. Now to find the distance, so recall we had our point P here and A, where PA is the radius. So in order to find the length of PA, which we can denote as this, we use Pythagoras theorem, and we do the difference in the x's squared plus the difference in the y's squared. Now it doesn't matter which way you do this as long as you stay the same. So as long as you do, so if you do x2 minus x1 squared, you then do y2 minus y1 squared, and so on. So let's do x2 minus x1, 7 minus 3 squared, plus 5 minus 7 squared. This is going to give us the square root of 4 squared plus minus 2 squared, which is 4, which equals the square root of 20. Right, so now we have that r, so recall PA is the radius, so r equals root 20, and we have the centre of the circle, which was 7, 5. Now we can use the equation of the circle here to write our equation of the circle. So we have x minus 7 squared plus y minus 5 squared equals r squared, which is 20. And I'm just checking that you don't need to simplify that any further. Nope, you don't. So that's fine like that. So that's part B. That's quite long for how many marks was that? That was 4 marks, and there was actually quite a lot of things you had to do. So let's have a look at part C. The line with equation y equals 2x plus k with k not equal to 1 is also a tangent to C. Find the value of the constant k. So the first thing to note that this line is not the same as L because k is not equal to 1. This simply means that it crosses the y-axis at a different point, but also the gradient is the same as L, which must mean that it's parallel to L. Something like that. So that's L, and that's our new line. So if we have the circle in between here, and this is a bad drawing, but hopefully you get the idea. Just try that again. Yeah, so if we have the circle, this new line is also a tangent to C. Now the way we figure out k is we look for the point where the circle meets the tangent. So where do we go? Let's start here. So this is part C. Let me draw that circle out again. So we had our circle, we had A, we had the tangent here. Bad drawing again. We had P. We've got this new tangent because these two lines are parallel because they have the same gradient. We know what PA is. Now let's have a look at this point here where the circle meets the tangent. So, and let's recall what these points were. So A is 7, 5 and P was 3, 7. Yep, 3, 7. So let's have a look what we've had to do to get from P to A, because as these lines are parallel, well, we'll then have to do the same thing. This can be explained using vectors, but I quite like this explanation. So to get from P to A, we've gone plus 4 in the x, and we've gone minus 2 in the y. So now to get to A, let's call this point D. Now as these vectors are parallel, we can do the same thing to D, plus 4 in x, minus 2 in y. So now to work out D, we just need to do 7 plus 4, 5 minus 2, which equals 11, 3. Now that's the point D, and it's a point on this line. And we know that if we have a point on a line, we can work out the constant. So we have y equals 2x plus k, and we have this point 11, 3 on line. So let's plug in x equals 11, y equals 3, implies 3 equals 2 lots of 11 plus k, and this rearranges to give us k equals minus 19. So there we go, guys, we've solved this question. It's quite long, but it was worth, what, 10 marks? Yeah, 10 marks, so it's a hefty chunk of the exam. So yeah, make sure you can do questions like this. Let's move on. Right, now we've got some integration. And we're given a positive integer k. So this means k is 1, 2, 3, ... This notation just means k can be any of these. So now we're asked to show that this integral is independent of k. to part A. So what we mean by independent is that the final answer doesn't depend on k. So let's do this integral. 2 over 3x minus k. Now you'll have, let me just change the colour again. So in the formula booklet there is a result that looks something like this. Dx equals natural log x plus c. And we can see that we have quite a similar thing going on here. We have that if we differentiate 3x minus k with respect to x, we get 3, which is nearly 2. And this is called integration by inspection, or just looking at what you're going to get, basically. So we have something that looks like the natural log 3x minus k. But then note, if we differentiate natural log 3x minus k, we get 3 over 3x minus k. So we need to adjust it by this constant here. Now if we differentiate this, we get 2/3 times 3, which is 2, divided by 3x minus k. I hope that makes sense. This is one of them things where the more you do, the more practice you get, the better you'll get at spotting them. And then it's a definite integral, so we need these limits. So now it's just a case of plugging in these values. So we've got 2/3 natural log 3 times 3k is 9k, minus k is 8k, minus 2/3 natural log 3 times k is 3k, minus k is 2k, and therefore we can use the rule of logarithms that if we have one log take another, the inputs are just divided like so. 8k over 2k. And then the k's cancel, 8 over 2 is 4, so we get 2/3 natural log of 4. Okay, so I hope that makes sense. If it doesn't, just pause the video and slowly go through the workings, and hopefully you'll get there. So the reason this is independent of k, because it doesn't depend on k, if that makes sense. Right, let's move on to part B. Let's change. So this time we've got a similar integral, but the denominator is squared. This time we're asked to show it's inversely proportional to k. So if something is inversely proportional to k, it means it's proportional to 1 over k. So that's what we're hoping the answer is going to be. This means like it equals some constant times 1 over k. Right, so let's write this integral down and have a go. So we have the integral from k to 2k, 2 over 2x minus k squared dx. Just let me check I've got that right. Yep. So now, although it looks the same, it's a completely different operation to integrate this. You've got to use the reverse chain rule. Now, one thing to do first, if you're not that comfortable with these type of integrals, is to rewrite the expression here, 2 over 2x minus k squared, as 2 times 2x minus k to the minus 2. So we just bring in the denominator up to the top, and this can help make it a little bit easier to see what to do. Now, to use the inverse chain rule, we add 1 to the power, so minus 2 plus 1 is minus 1. We times the power by the differential of what's inside the bracket here, which is 2. So we've got minus 1 times 2, and then we divide the whole thing by that. So we've got 2 over 2x minus k to the minus 2, which gives us minus 1 over 2x minus k. And yeah, don't forget, all this is still a definite integration. This is going to look really messy, so I apologise. But yeah, that's the idea. 2k, k. So let's carry this out on the next page. Let's keep it there so I can see. Equals, it's minus 1 over 2 times 2k is 4k minus k is 3k. And then we've got a minus 1 over 2 times k minus k is k. So we've got minus 1 over 3k plus 1 over k. Let's check I've got this right. Yep. So now in order to add fractions like this, we need to get the second term having the same denominator. So we get this is equal to minus 1 over 3k plus 3 over 3k, which equals 2 over 3k. Now we can see that this is of the form, so 2 over 3k equals 2/3 times 1 over k, and hence the integral is indeed inversely proportional to k as required. So I hope that makes sense. I know it's quite long-winded. But yeah, do let me know if there's anything I'm not explaining properly as well, guys, because this is my first tutorial, so I'm just learning the basics. So let's move on to question 8. We've got the depth of water being modelled by a formula. So let's change the pen colour, as I'm not the biggest fan of red. So we have T is the number of hours after midnight, and here we go, let's move to part A. So we have a boat enters the harbour at 6:30 AM and it takes 2 hours to load. The boat requires the depth of water to be at least 3.8 before it can leave the harbour. So find the depth of the water when the boat enters the harbour. So we know the boat enters the harbour at 6:30, and T is the number of hours after midnight. So we need to work out what T is when the boat enters. So we're going from midnight, which is 00:00 to 6:30. And this is 6.5 hours, so it implies T equals 6.5. Now all we've got to do is plug in our value for T into D. So let's go ahead and do that. And don't forget you've got a calculator to do this as well, so you're not expected to work things out like sine 30 times 6.5. So D equals 5 plus 2 sine 30 times 6.5. And this is going to be in degrees. So let's do that on the calculator. And don't forget to put your calculator in degree mode rather than radians if it is. 2 sine 30 times 6.5. And you should get an answer of 4.48 meters. So 4.48 meters is the depth of the water in the harbour. Right, so that's part A. Quite a simple 1 mark question there. Now part B, find to the nearest minute the earliest time that the boat can leave. So there's a few things we have to do here. Firstly, we know that the depth of the water has to be at least 3.8 meters. So let's start by setting D equals to 3.8. And now we can use the formula to say that 3.8 equals 5 plus 2 sine 30t. And let's just rearrange this. So we're going to get 2 sine equals 5 minus 3.8, which is minus 1.2. And therefore sine of 30t equals minus 0.6. Now from there we have to, in order to get the value 30t, we need to work out the sine inverse. So use the sine inverse function on your calculator. So let's do that. So sine inverse of minus 0.6 is minus 36.86. .869, whatever. Now, note that even if we divide this value by 30, so let's do that, that gives us minus 1.23. This value is not in range, as here t needs to be between 0 and 24. You can't have negative hours. So what we need to do is, using what we know about trigonometric functions, is adjust this value. So the first way we do this is we get 30t equals this answer, and we take this away from 180. It's minus 36.869, which gives us, so it's 180 minus 36.869. It's 216.869. 216.869. And then now let's try dividing that by 30 and see if it's within range. So this is going to give us 7.23. So you might think here this is the answer, as 7.23 falls within this range here. But we've got to also note the boat requires the depth of the water to be at least 3.8 hours. Yeah, we've got that. And it also takes 2 hours to load the cargo. So this means it can't leave any earlier than 8:30. And this contradicts this value of t, because this would mean approximately 7:15 a.m. the boat leaves, which it can't because it's not loaded yet. So we need to go to the next value, and we get the next value by doing 30t equals our minus 36 point, what was it, 869 plus 360 degrees, which gives us 323.131. Now divide this by 30 and we will get 10.77. So we're thinking, okay, great, this is within range and the boat will have loaded its cargo by then, but this is not the final answer yet. So we need to convert this into hours. So we know that it's 10 hours, and then the 0.77 we times by 60, so 60 minutes in an hour. And this gives us about 46.2. So now that's minutes, min. Now what you don't do here is write 10 hours 46 minutes, because it asks what time, the earliest time. So what you should write here is 10:47 a.m. and that is the earliest time the boat can leave the harbour. I think in the mark scheme it'll also give you it if you write 10:46 as well, but I always think of it, it's not 46 minutes exactly, there's something after. So right, let's move on to question 9, and we have a sketch of a curve which involves both x and y. It's not just a y equals function. And when we've got a curve with an equation like this, it's probable that we're going to have to use some implicit differentiation. And we're asked to find the derivative, so let's go ahead and do that. So we have the equation x squared minus 2xy plus 3y squared equals 50. So let's differentiate this. We're differentiating with respect to x. So the first term becomes 2x, as we know. This second term is a product. It's a product rule. So we'll just 2xy. So u equals 2x, v equals y, u primed equals 2, v primed equals 1. Then we do the usual. In fact, I've made a mistake there. V primed is actually dy by dx, because we're not differentiating y with respect to y. So yeah, that was my mistake. So that's where the implicit differentiation comes in. And we actually get, so the product rule, u times v primed plus v times u primed. So we get 2x dy by dx minus v u primed 2y. Again, similarly, to differentiate this 3y squared, we use implicit differentiation again, and we get 6y dy by dx. And then 50 goes to 0 because it's a constant. So now all we have to do to find dy by dx is rearrange this, and we get dy by dx. So we've got, on the left hand side we have a 6y minus 2x. We move the 2x and 2y over to the other side to get 2y minus 2x. And I know I'm doing a couple of steps in one here, but if you do it one step at a time, you'll get the same answer. And therefore we get dy by dx equals 2y minus 2x over 6y minus 2x. And then we can divide everything by 2. There's a common factor there to get y minus x over 3y minus x. And this is the required answer here. Right. Part B, find the exact coordinates of the point P. We're also told that the points P and Q represent the furthest west and the furthest east of the origin. Now note that the tangent to this curve at the point P, which is this line, has its gradient is infinite, essentially, which means that, so I'll just write it here, at P, dy by dx tends to infinity. It's not quite infinity because this line has infinite gradient, but at P it's tending there. And similarly at Q, because we have this line here. So now all we need to do is work out when the gradient tends to infinity. So let's do that. So let's write down our dy by dx again. Y minus x over 3y minus x. Now at P, this tends to infinity. And this means that the denominator gets very, very small. Because if you're dividing something by something very small, you're going to get a very big answer. So at P, we get 3y minus x equals 0. This gives us that y equals a third x. Now in order to find the coordinates of the point P, we need to solve the equation of this line. So what we've actually worked out there is an equation of some line y equals a third x. So I don't know, so it's something like that. And in order to find the coordinates of the point P, we need to solve simultaneously the equation of this line, let's call it L, and our curve. So let's write that down. Let's change colour. I'm going to put solve simultaneously with our x squared minus 2xy plus 3y squared equals 50. Just check I've got that right. Yep. So all we have to do is plug in y here. So let's call this 1, this 2, 1 into 2. So we get x squared minus 2x, lots of a third x, plus 3 lots of a third x all squared, and this equals 50. So here we're just solving simultaneously to find the point P. So let's simplify this. We get x squared minus 2/3 x squared plus 3 lots of a third squared is 1/9, so we get 1/3 altogether equals 50. Now we just got to simplify these. So x squared, we've got 1 lot of x squared taken away 2/3 of x squared plusing a third of x squared. This is going to give us 2/3 of x squared in total. And then this equals 50. We can simplify even further to get x squared equals, so you times in by 3 is 150, divided by 2 is 75. And then we get, take the square root, plus or minus 75. Note this is plus minus 25 times 3, and then square root of 25 is 5, so we get plus minus 5 times square root of 3. Now we've just got to use the equation y equals a third x to find y. So let's do that. Okay, so if x equals 5√3, y equals 5√3/3. Similarly, if x equals, minus 5√3, y equals minus 5√3/3. So there we go, we've got two solutions, but we're not finished yet. Note that we were asked to find the coordinates of P, and in P both x and y are negative. So therefore we ignore these two solutions and we use these two. So we get, therefore P equals minus 5√3 minus 5√3/3. So that's the answer for part B. Now let's have a look at part C. It's only a 1-mark question. Explain briefly how to find the coordinates of the point that is furthest north of the origin O. You do not need to carry out this calculation. Well, it's a similar process. So in order to find the point that's furthest north, which is somewhere around there, we draw the tangent, something like that. And we observe at this point that dy by dx is tending to 0. This is because horizontal lines like this have no gradient. And so we do a similar process in that, there we go, part C. So our dy by dx was y minus x over 3y minus x. And let's call this point, what we were looking for, the northest point, point N. So at N, dy by dx tends to 0. Now how do we get this quotient to 0? Well, there's two ways. The denominator can tend to infinity, or the numerator can tend to 0. So at N, y minus x equals 0, which implies y equals x. We do a similar process to before. So to find n, solve y equals x simultaneously with our original curve, x squared minus 2xy plus 3y squared equals 50. And don't forget, we'll get two solutions just as we did above here. And as we're looking for the most north point, both x and y are positive. If we were looking for the most south point, that would be down here somewhere. We'd have x and y negative. So this time, rather than take the negative solution, we take the positive solution. So you need to write that in, otherwise you won't get the mark. And take positive solution. So there we are, guys. That's question 9 done. Let's move on to question 10. Okay, so question 10, we have this differential equation here which models the height above ground of passengers on a roller coaster, where t is the time in seconds from the start of the ride. We're given that the passenger is 5 meters above the ground at the start, so we're asked to show that h equals 5e to the 0.1 sine of 0.25t. Now, in order to do this, we're going to need to separate the variables. So I always like to write down our equation down here, which equals h cos 0.25t divided by 40. Separating the variables gives us the following. So we get dh by h equals cos 0.25t divided by 40 dt. So what we've done from this first equation is just times through by dt and divide by h. Now we can easily integrate both sides of this to get the following. So on the left hand side we could just get natural log of h, because when we differentiate this we get 1 over h. And on the right hand side, cos integrates to sine, but we also need to divide through by a quarter. So what we actually get is sine 0.25 t divided by 40, but then we're dividing by a quarter, which means timesing by 4 plus c, and this equals sine 0.25 t over 10 plus c, just by cancelling down the fractions there. So now what we need to do is use the information that we were given at the start, namely the passenger is 5 meters above the ground at the start of the ride. So this means when t equals 0, h is 5. So let's do that. When t equals 0, h equals 5. So we get natural log of 5 equals, now sine of 0 is 0, so we just get that c is equal to natural log of 5. Now, from there we get natural, plugging in c back into our equation, we get sine 0.25t over 10 plus natural log of 5. We can simplify a little bit further by bringing the natural log of 5 over to the left hand side, and we get natural log h divided by 5 equals, so it's 1 over 10. It's easier to write it like this now, 0.25t. Now what we do is we exponentiate on both sides, and I'm also going to write the 1 over 10 is 0.1, as that's how the question wants it. So this gives us, what have we got? H over 5 equals 0, e to the 0.1 sine 0.25t. And this, now we just multiply through by 5 and we get the answer we're looking for. H equals 5e to the 0.1 sine 0.25t. That is the required answer. So moving on to part B now. State the maximum height of the passenger above the ground. So we look at our formula for h here, and we consider the right hand side, because we want to know how big h can get. And we also know that sine is a function that goes between 1 and minus 1. So we want to look at when sine equals 1. So let's just set sine, so this is part B here. So let's set sine of 0.25t equals 1. We're not too bothered about which value of t makes it this for now. And therefore we get h equals 5e to the 0.1. And we work this out on our calculator. We get to the power of 0.1. We get 5.53. And that's in meters. So that's part B. That's the highest possible height that the passenger reaches. So yeah, note in that question we weren't asked to find the t that makes it that height. Now it says the passenger reaches the maximum height for the second time t seconds after the start of the ride. So this time we're looking for the value of t that makes our height 5.53. So what we need to consider here is which values of t make sine 0.25t equal to 1. And in order for that to happen, we need 0.25t to be equal to pi over 2, 5 pi over 2, etc. Now, our first value corresponded to this pi over 2, so we set 0.25t equals to 5 pi over 2, and this gives us that t equals, so it's 5 pi divided by 2, and then times by 4, it's 10 pi, which equals 31.4 if you want it in decimals. And that is the value of t that gives us the value 5.53 for h. That's the final answer for question 10. Hope that makes sense. Do let me know if I've made any errors. Right, question 11. We've got some binomial expansions here. And we're asked to show that this complicated looking square root is approximate to 1 plus 5 over 2x minus 5 over 8x squared. So it's 6 marks for this, so it's definitely something you need to know how to do. And let's first write out, so part A. Let's first write out this square root in an easier way to understand. So 1 minus x, this equals square root of 1 plus 4x over square root of 1 minus x. That's just a simple property of square roots, of quotients. And then we can rewrite this further by using indice notation. So this is 1 plus 4x to the half over 1 minus x to the half. And then we can bring the denominator up to the top. And this should make it easier to perform a binomial expansion. Minus a half. Now all we have to do is use the formula for the binomial expansion to calculate these two terms. So 1 plus 4x to the half is 1 plus, and then it's a half times, don't need that, half times 4x plus a half times minus a half times 4x squared over 2 plus dot dot dot. So yeah, we're not bothered about the other terms as we're only asked to find the three terms. Similarly, 1 minus x to the minus a half is approximately 1 plus minus a half times minus x plus minus a half times minus 3 over 2 times minus x squared over 2 plus and so on. Simplifying these down, we get the following. 1 plus 4x to the half is approximately 1 plus 2x. And here we've got a half times minus a half is minus a quarter. 4x squared is 16x squared. So that gives us minus 4x squared, sorry. And then divide by 2, we get minus 2x squared. And that's our final approximation. Similarly, 1 minus x to the minus a half is approximate to 1. So we've got minus a half times minus x, so it's plus a half x. And then we've got minus a half times minus 3 over 2, which is 3 over 4, times x squared over 2, which is 3 over 8. Okay, so now all we have to do is multiply these together, as we observed up here. And this will give us, hopefully, the answer. So now we have 1 plus 2x minus 2x squared, 1 plus a half x plus 3 over 8x squared. And now it's just a case of expanding this out. So we've got 1 plus a half x plus 3 over 8x squared plus 2x plus x squared, that's that, plus 3 over 4x cubed. Now there's going to be extra terms here. So what else? We've got minus 2x squared minus x cubed and then minus 3 over 4 x to the 4. And the only terms we're interested in are up to the quadratic, so let's just concentrate on those. So we have a 1. For the x's we have 5 over 2, 5 over 2x, that's combining this term and this term. We've used the 1. The x squareds, we have 3 over 8x squared plus x squared minus 2x squared, and that's going to give us minus 5 over 8x squared. Yeah, because we've got 3 over 8 plus x squared, which is 8x squared over 8, it's 11 over 8x squared, minus 16 over 8x squared is minus 5 over x squared. So we've neglected these terms here. So hopefully that makes sense, and that is the answer we were looking for, as we can see. Now, a student substitutes x equals a half into both sides of the approximation shown in part A in an attempt to find an approximation to root 6. Give a reason why the student should not use x equals a half. Well, this comes down to what values of x the binomial expansion is valid for. So we performed binomial expansion on 1 plus 4x to the half. Now this is valid for when 4x is less than 1, and so x is less than a quarter. and therefore, where are we? A student uses a half, so yeah, the student should not use x equals a half because obviously a half is bigger than a quarter. So let's just write that down. Shouldn't use x. Clearly. So that's our answer for that. That's just a 1 mark question there. Finally, substitute x equals 1 over 11 into our answer to obtain an approximation to root 6. So let's go ahead and do this. So part C then, substituting x equals 1 over 11. So what do we have? 1 plus 4 lots of 1 over 11 divided by 1 minus 1 over 11. And we can expand this out. So we've got 15 over 11 on the top, like so, divided by 10 over 11. So when dealing with fractions like this, you flip the second one and multiply. The 11s are going to cancel, and you're left with root 15 over 10, which equals root 3 over 2. And then separate the surds like so. Now we're going to rationalise the denominator by multiplying by root 2 on both sides. And so we get root 6 over 2. So what we're actually approximating is root 6 over 2. So root 6 over 2 is approximately 1. What was our answer? 5 over 2 times 1 over 11. And then minus 5 over 8 times 1 over 11 squared. So this is approximately 1 plus 5 over 22 minus 5 over 8 times 1 over 121. Let's use our calculator to find this, as it'll save us some effort. So 1 plus 5 divided by 22 minus 5 over 8, 1 over 121. Now this should give you a fraction, and it is 1183 over 968. Now recall that the question asked us to find an approximation to root 6, so all we have to do is multiply both sides by 2, as we just approximated root 6 divided by 2. So we get root 6 is approximate to 1183 divided by 484. And that is the final answer for that question. So quite a long question, but also quite nice. Right, let's move on to question 12. And we have another modelling equation here. The value in pounds V of a vintage car 2 years after it was first valued on 1st of January 2001 is modelled by this equation. So V equals AP to the T. So again, we're given some information. Given that the value of the car was £32,000 on 1st of January 2005 and £50,000 on 1st of January 2012, firstly we've got to find P. So let's go ahead and do this. So we have our equation V equals AP to the T. We also have that when T equals 4, V equals 32,000. So when T equals 4, V equals 32,000. And we also have when T equals 11, V equals 50,000. That's just interpreting the two statements above. So let's plug these into our formula. Let's call these 1 and 2. So for number 1, we get 32,000 equals AP to the 4. For number 2, we get 50,000 equals AP to the 11. Now we're asked to find P here. So the easiest way to do this is to divide 50,000 by 32. Well, divide the second equation there by the first equation. So let's go ahead and do that. So we get 50,000 divided by 32,000 equals AP to the 11 over AP to the 4. The A's are going to cancel, and we have the standard indice rule here. So this gives us P to the 7. Now all we have to do is take the 7th root of this as follows. So P equals the 7th root of 50,000. And don't worry, you don't have to do this in your head. There's a nice handy function on your calculator. So let's go ahead and do that. 7th root of 50,000 over 32,000. And this gives us the answer 1.0658 and so on. But we're not too bothered about the numbers after. So that's our P. Right. So that's a nice couple of marks there. Well, it actually said find P to 4 decimal places, so that's what we've done. Now, show that A is approximately 24,800. So we now have our equation V, this is I believe, equals A times this 1.0658 to the T. And we need to use the equations above as well. So we had 32,000 equals A times 1.0658 to the 4. And now all we have to do is divide both sides by 1.0658 to the 4, and this will give us the answer. A equals 32,000 divided by 1.0658 to the 4. And this is going to give us the answer 24,799 and some dots. Let me just check that. Divided by 1.0658 to the 4. Yeah, 24,799.74 and so on. And the question asked us to show that A was approximately 24,800, and so it is. A is approximately 24,800. Cool, so that's part II. Now let's have a look at part B. With reference to the model, interpret the value of the constant A. Oops. Now let's write down our V again. So we had V is 24,800 times 1.0658 to the T. And it's asked us, what does this 24,800 mean? So notice at time t equals 0, we get V is 24,800. Hence, 24,800, which equals A, is the initial value of the car. So that's that. That's part BI. Part BII, the value of the constant P. So P, which equals 1.0658, is the increasing factor. Now there's a couple of different ways you can write this down, but I like, it's the factor in which V increases. V increases, and that's every year. So that's that. Let's have a look at part C. Using the model, find the year during which the value of the car first exceeds £100,000. So note, it's not looking for the value of t, it's looking for the actual year. So it's always important to read the question and actually look what it's asking. Right, so let's go ahead and do this. Let's have a change of colour. Let's go for a red. C. So let's write down our equation again. So it's 24,800, times by 1.0658 to the t. And we're looking when the value reaches 100,000. So let's plug in that to V. So we get 100,000 equals 24,800 times by 1.0658 to the t. Now we divide both sides by 24,800 to get the following. 24,800 equals 1.0658. There's a 1 there, to the t. And now we take the log base our constant p. Hopefully I'm going to be able to write this. 1.0658 of this quotient here. 24,800 equals t. This is because we're taking the log base 1.0658 of 1.0658, and we have the two following rules, so I'll just write these in a different colour. So we have, for any base a, log a of itself is 1, and we also have, log a b to the m equals m log ab. So combining these two rules is how we get the t on the right hand side there. And now all we've got to do is plug this into our calculator and we get the answer. T is 21.9. Now remember I said that this isn't the final answer. So what we actually have to do is sort of convert this into years. So it's 21.9 years. And then looking at the question, this car started in 2001. So adding on those 21.9 years, we're going to end up in the year 2022. So just as a closing line then you say, the car, or it actually says, the car first exceeds 100,000 in the year 2022. That's the final answer for that question. Moving on. So now we've got a pretty complicated looking integral here, and it's a 7-mark question. There are a couple of ways you can go about this, namely integration by substitution or using integration by parts. Here I'm going to use integration by parts because I quite like using by parts. But if you would like to see the alternative solution with integration by substitution, then do let me know. I'm quite happy to go through that as well. First, let's recall the formula. So if we have an integral like this, so it's two functions, one's u and one is a derivative, and this is integrated with respect to x, then we actually have uv minus v du by dx. This follows directly from the product rule. So again, if you'd like me to do a video explaining where this formula comes from, then I'm happy to do so. So now let's look at our formula, or our integral here. We have, it's a definite integral as well. So we have 2x, x plus 2 dx. Now what we're going to do here is set u to be equal to 2x, and our dv by dx equals root x plus 2. Now it's just a case of finding u prime and v. So u primed is quite simple, it's just 2. To find v is a bit more complicated. We have to use the inverse chain rule. So let me just write out this as x plus 2 to the half, as so. So to integrate x plus 2 to the half, we take the half, we add 1 to the power, so that's 3 over 2. We times by the differential of whatever's in the bracket, which is just 1 because the coefficient of x is 1. And then we divide by this. So we're dividing by 3 over 2. So we get 2 2/3 x. Sorry, my bad. 2/3 x plus 2 to the 3 over 2. A quick check when you differentiate this will tell you that you get the square root of x plus 2 back, as you do 3 over 2 times by 1 times by 2/3, take 1 off the power. So now all we have to do is plug this into our integration by parts formula, which is here. So let's go ahead and do that. So we've got the integral to 2x, x plus 2 dx equals uv. So it's 2x, and this needs to be evaluated, times 2/3 x plus 2 to the 3 over 2, and that's between 0 and 2. And then we're taking away another integral between 0 and 2, and this is v du by dx. So v, 2/3, and then x plus 2 to the 3 over 2, and then du by dx is 2, so times by 2 there, dx. Now before we tackle this first one here, let's actually integrate the second term and get it all together. So I'll just write that down again, but we'll simplify. So we get 4x over 3 times by x plus 2 to the 3 over 2, and that's evaluated between 0 and 2. Now to integrate this this part here, we add 1 to the power to get 5 over 2, times it by the coefficient of x in the brackets, which is 1, and we then divide 4 over 3 by 5 over 2. So if I've done that right in my head, I should get, so 5 over 2 going to give you 4 over 15, I believe. Just check that. Yep. So you get 5 over 2. 8 over 15, sorry, my bad. Got lost with the 2 there. 8 over 15 times x plus 2 to the 5 over 2. And that's between 0 and 2. Let's just check by differentiating that. So we get 40 over 30. Yep, so that's all good. Now we can bring these two together if we want, but I'm just going to do them separately because that's fine. So the first term, we get 4 lots of 2 over 3, and then we've got 4 to the 3 over 2. Let's keep this nicely bracketed here. And then the second term is going to give us 0 because 4 times 0 is 0. And then we're taking away the result of the second integral, which was 8 over 15 times by x plus 2 to the 5 over 2. So 2 plus 2 to the 5 over 2. And then we're taking away 8 over 15 lots of 2 to the 5 over 2. Have I missed something here? VDU? Nope, we're all good. Not missed anything. So it's 2 to the 5 over 2. Now I've just realised I have made this a bit harder for myself by not combining the two results into one bracket, but never mind, we don't mind that. So we have 8 over 3 times by 4 to the 3 over 2, which is 8. And then we're taking off. Now it's important not to forget your minuses here. So we've got 8 over 15, and then we've got 4 to the 5 over 2, which is 2 to the 5, which is 32. And then we've got 2 minuses make a plus, 8 over 15, and we've got root 2 to the 5. Now let's just stop a minute there and we can note that, so root 2 to the 5, I'm just going to write it out long way, just so we can see what's going on. Root 2 times root 2, is that 5? Yep. So anytime there's two root 2's next to each other, we can make a 2. So we've got 2 times root 2, which equals 4 root 2. And this should help us to simplify a little bit. So going back to the above, we now have, so 64 over 3 minus 8 over 15 times 32 plus, and using what we've just got, we've got 32 over 15 times root 2. Now, we don't need to bother with a calculator here, but we can do. So let's convert this first term into being something over 15. So we want that. So we need to times top and bottom by 5. 64 times 5 is 320. So we have 320 minus 8 times 32 is 256 over 15 plus 32 root 2 over 15. Now it's just a case of simplifying here. We have 64 plus 32 root 2 over root 15. And let's have a look what form it asked us to put it in and hope we've got it right. So yeah, we just need to factor out 32. 32. Oh, why have I wrote a root 15 there? Very silly. It's been a long day. So 15, 32 over 15, 2 plus root 2. And that's our final answer. Good. So now I believe we're moving on to the final question. So last but not least, question 14. We've got these parametric equations describing a curve C. X equals 3 plus 2 sine t, y equals 4 plus 2 cos 2t. T is between 0 and 2 pi. So part A, show that all points on C satisfy y equals 6 minus x minus 3 squared. couple of ways you can do this, but I like the following. So using the first equation, let's make sine t the subject. So sine t equals x minus 3 over 2. And with the second equation, let's make cos 2t the subject in a similar way. Cos 2t y minus 4 over 2. Now we use the formula for cos 2t, which says cos 2t equals 1 minus 2 sine squared t. And we already have a formula for sine t, so we can use this. So let's do this. So call this equation 1, equation 2, 3. So we're going to input 1 and 2 into 3. So we know that cos 2t is this y minus 4 over 2. 1 minus 2, and then sine squared t is x minus 3 squared, x minus 3 over 2 squared. Okay, so now we can multiply by 2 to get y minus 4 equals 2 minus 4 x minus 3 over 2 squared, and y minus 4 equals 2 minus, and then this x minus 3 over 2 squared is x minus 3 squared over 2 squared, which is 4. So we're just going to get x minus 3 squared like that. And then all we've got to do to get it in the required form is to add 4 to both sides. I'll save that space there. So we get y 6 minus x minus 3 squared. And that is the answer we were looking for. So we now know that all points on C satisfy that equation for y. So part B, we're asked to sketch the curve C, which is why I left this space here, but I'll just write our equation out again. Minus 3 squared. I'll also write the parametric equations, which were x equals 3 plus sine t, y equals 4 plus 2 cos 2t. So from our equation for y, we can see that, so this is x, this is y, we can see that there's going to be a maximum point at 3, 6. That's somewhere around here. This is, we can just read this straight from this formula here. That's because it's in completed square form. We also know it's a negative parabola because we have a negative x squared. Now all we have to do is find the minimum and maximum points of the curve. And these are due to the fact that sine goes between 1 and minus 1. So I'll summarize that as minus 1 less than sine t less than 1, x, let's write, we have, so no, if sine t, so I'm looking at this equation now, if sine t is minus 1, then we have x is 1. So that's the worst case scenario for sine, if you like. And then if sine is 1, we have x is 5. This is our domain. So now, as we have the domain for x, we need to work out what y is at these endpoints. So when x equals 1, y equals, and we're using this top formula here, this one. So if x is 1, we have 6 minus 1 minus 3 squared, which is 2. And when x equals 5, y equals 6 minus 5 minus 3 squared is 6 minus 4 again, so it's 2 again. So this means we have the following curve. Let me just draw that in. Okay, so we have our point 1, 5, and 2. So we have something like this. And now that's not the best of drawings, but it'll do for now. So this is the one end point, and this is the other end point. So that's how you draw the parabola for y, or for c there. Now explain briefly why c does not include all points of y equals 6 minus x minus 3 squared, where x is a real number. And we've already sort of answered this. It's because of this restricted domain here. X can only go between here because we've described x using this parametric equation here. And because sine has a restricted domain, therefore so does x. Okay, so that's part B. Now we have the line with equation x plus y equals k, where k is a constant, intersects c at 2 points. State the range of values of k, giving your answer in set notation. So the first thing to know is rewriting this gives y equals k minus x, which implies gradient is negative. In fact, it's minus 1, so let's have a look at our graph here. Because the gradient is negative, it means this y equals k minus x line must be something like this. The gradient's negative. Now, if we can keep drawing these lines, I'm doing my best to make them parallel. Note that any line which does not pass through 5/2 there, cannot intersect the curve at 2 points. So values of k for which this line intersects the curve twice have to come from values of x which are bigger than 5. But for the minimum value of k, we use this 0.52. So k equals x plus y, which is 5 plus 2, which equals 7. So what I mean by this is this value here, I'll just draw there. So this line here, this one, this is the first line that can intersect the curve twice if we're going off x values. Now obviously any curve after here does intersect the curve twice, and we need to find the range of values for which. So eventually we'll get to some point y, say up here, where it no longer intersects at all. And we need to find this value. So I hope that that explanation of why k equals 7 is the minimum value of k for which this line intersects twice makes sense. Again, please let me know if it doesn't. So the main thing is, because the gradient is negative, some lines only intersect once, some don't intersect at all. But essentially, as we move up the y-axis, the lines start to intersect twice when we reach this endpoint 5,2 here. Okay. So, this was part C, I think. So yeah, we have this line, y equals k minus x, but we also have this expression for y equals 6 minus x minus 3 squared. Now all we've got to do is solve these simultaneously. So we get k minus x equals 6 minus x minus 3 squared. This gives us k minus x equals 6 minus, be careful of your brackets here, because this can easily catch you out. And now all we have to do is rearrange. So we get x squared, we have a plus 6x on this side, so take it away, we got another minus x, so we got minus 7x. 6 minus 9 is minus 3, it's plus 3 plus k. Now recall that we're looking for values of k such that it intersects twice. So we want when b squared minus 4ac is greater than 0. So let's calculate b squared minus 4ac. So it's minus 7 squared minus 4 times 1 times c, which is this whole term here, 3 plus k, which equals 49 minus 12 minus 4k, which equals 37 minus 4k. Hence, b squared minus 4ac is greater than 0 if 4k is less than 37, and hence k is less than 37 over 4. So if I quickly try to explain this again, if I just draw the graph roughly. So eventually we get to this value 37 over 4, which does something like that. And then we had our value, where was it? Something like that, where this was our 5,2. So this is our possible domain for values of k, which intersect the curve twice. So basically any line that lies in here will be fine. Okay, so our final answer, and it did say in set notation, so range equals, it's all the k such that k is bigger than or equal to 7, because as we said before, that's this, or it's now less than 37 over 4. So it's a bit of a horrible question this, but it is the last question and you do expect to be challenged by these. I hope this explanation makes sense. And yeah, this diagram isn't really the best, but hopefully it makes sense what I'm trying to say. So we've reached the end of the paper now. This was my first paper going through it like this, so I'm still learning, but if you have any feedback or comments, do let me know. I'll be more than grateful to receive any comments or feedback. So stay tuned for the next papers coming up very shortly. I'm going to try and get through the Edexcel papers first. So thanks very much for watching and see you next time.